Hello, everyone. Mrs. Raposa here. We started these notes on Thursday, May 18th in class on section 8.4, the trig identities and theorems, but we didn't get very far. So I'm going to have you finish taking the notes today while you watch this video as though I was there teaching you. The beauty of the video is that you can pause and get a closer look if you need to, or rewind, or go back if you didn't catch what I was saying. All right, so if you need a review of the theorems that we filled in on May 18th, I'm going to ask you to take a look at what I'm going to call the May 18th lesson video. But in this video, I'm just going to pick up right where we left off last class on May 18th. Okay, one of the most important identities you'll learn in pre-calc is the Pythagorean identity. And it basically comes from the unit circle. So I tried to draw a unit circle very quickly last class, but I don't know how well I explained it because we were rushing. So I drew the unit circle again over here for you. A unit circle is a circle with the center at 0, 0. And the radius is equal to exactly 1 unit, not 2 units like we sometimes use with the 30, 60, 90s. But in this one, the radius is only equal to 1. Well, since the rotation here is theta, whatever it's degrees or radians, this angle rotation, this reference angle will be theta. I put it in first quadrant to make it simple, but you could do it in any quadrant. The cosine of this angle measure will equal the x coordinate divided by the radius. But the radius is 1. So basically, the cosine of this angle measure is equal to x itself. X over 1 is just x. And the sine of this angle measure is equal to y over 1. So just y. Sine theta is equal to y. So if you take the point 1, 0 and rotate it anywhere on the circle around the origin, then the coordinates of that point will be whatever cosine of that angle measure is and sine of that angle measure is. So that's the unit circle. What we have here really is a right triangle. And we know that a squared plus b squared will always equal c squared. So remember, on the unit circle where the radius is 1, x is really just cosine theta. And y is just sine theta. So what we really have is cosine theta squared plus sine theta squared is equal to the radius squared, which is just 1. And that's how we end up with sine squared plus cosine squared equals 1. Keep in mind that when we write sine theta squared, we don't square the angle measure. We take the sine of that angle measure, whatever that angle measure is, we find the sine ratio, like the sine of 30 degrees is 1/2. So we would square 1/2 and get 1/4. And you can try it with anything if you want to. If you want to pause the video, it's kind of cool. Sine 30 degrees plus the cosine of 30 degrees. Square those both. Square the sine. Sine of theta is 1/2. Sine of 30 degrees is 1/2. Square it. The cosine of 30 degrees, that's root 3 over 2. And square that. You'll just get 1/4 plus 3 over 4. Root 3 times itself over 2 times itself. And yeah, that'll equal 1. You can do that with any angle measure. Okay, now let's look at where these two identities come from. It actually comes from this by just doing some division on each side of the equation. On the back of this is where we are going to prove that these identities are also true. You have a backside. I don't mind single-sided. But on the backside of that, it looks like this. I got you started last class by telling you to divide each side of this equation by cosine squared. I'm just going to try to enlarge this a little bit. Here we go. So the original equation, like we said before, was sine squared theta plus cosine squared theta equals 1. That's your Pythagorean identity. What I'm going to do is I'm going to divide both sides of the equation by cosine squared. Divide this by cosine squared theta, divide this by cosine squared theta, And remember, we kind of share the love here. So sine squared over cosine squared. I'm not going to write it out, but this is really just sine theta over cosine theta times sine theta over cosine theta. So that's just really tangent times tangent, or tangent squared. So this just becomes tangent squared theta, this term. We're going to add it to cosine squared theta divided by itself. That's just 1. So tangent squared theta plus 1 equals 1 over cosine squared. That just means 1 over cosine theta times 1 over cosine theta. 1 times 1 over cosine times cosine. 1 over the cosine, that is the secant. So really this becomes secant times itself, or secant squared theta. So that's how we come up with this trig identity. I think I have tangent squared plus 1 equals secant squared, and over here it's 1 plus tangent squared, same thing. You can add in any order, okay? I'm not even going to do this one with you. I want you to try this one on your own. I want you to divide each side of the equation. Let's start with this again. So sine squared theta plus cosine squared theta equals 1. And go ahead and divide. Let me zoom out. It's kind of hard to see what's going on here. Go ahead and divide each side of the equation by sine squared theta. And share the love over here. You'll see you'll get this. Okay, let's talk about the cofunction relationships. On page 318 of your textbook, there's a great explanation of what cofunctions are. There's a lot to remember in trig. There's the inverse sine, inverse cosine, inverse tangent. Those give you angle measures. Then there's the reciprocal of the sine function, and the reciprocal of the cosine, and the reciprocal of the tangent. That's going to give you cosecant, secant, and cotangent. Now we have a third thing called cofunctions. At the top of page 318, which I'm just going to stick in here for just a minute, they really tell you that sine and cosine are cofunctions, and so are tangent and cotangent, and secant and cosecant. Not the same as reciprocal functions, okay? Cofunctions really deal with complementary angles. And recall from geometry that complementary angles are two angles that add to 90 degrees, as opposed to supplementary angles, which add to 180 degrees. So over here, we have a right triangle. In any right triangle, any reference right triangle that you're going to draw on the coordinate plane, you're going to have a right angle here, which means that these two angles are complementary. If this one is 16 degrees, then this angle is 90 minus 16. These two angles have to add to 90 degrees, so they're complementary angles. So let's take a look at the relationship between the sine of an angle measure and what happens when you take the sine, cosine, or tangent of sine of an angle measure and the cosine of its complement, really. On the back of this, I'm going to do that first. On the back of the sheet, which mine is not double-sided, so this is what it looks like on the back. I kind of drew some examples of cofunction relationships. We're going to compare the sine of 30 degrees to the cosine of 60 degrees. I drew a 30-degree reference angle in quadrant 1 and labeled the y, x, and r. I did the same thing with a 60-degree angle over here. Well, remember that sine of 30 degrees, that's just y over r, and in this case, y over r is 1/2. And the cosine of the complement to a 30-degree angle, that's the cosine of 60 degrees, that's going to be x over r, which is also going to be 1/2. Now, I used a 30, 60, 90 triangle to show you this, but that happens with any triangle. Remember that this triangle is the same as this triangle. It's just flipped around. That's all. This angle is here, and this angle 60 would be over here. So the y and x swap places. Same would happen if you had a 20-degree angle and a 70-degree angle. This y coordinate is across from the 20-degree angle. So across from the 20-degree angle would be whatever y coordinate's here, as long as the radius is the same. We'll say it's 1. as long as this radius is the same as this radius, this y-coordinate now becomes this x-coordinate. And this x-coordinate now becomes this y-coordinate. So y and x kind of swap places for complementary angles. So let's go back to fill this in. The sine of 90 minus 60, that's the same as the cosine of 60. So sine of an angle measure is going to be the cosine of its complement. Okay? Sine and cosine are cofunctions. So cosine of 90 minus x, that'll be the sine of x degrees. And tangent and cotangent are also cofunctions. So we'll have the tangent of 90 minus x is going to equal the cotangent of x degrees. Okay, as for the reciprocal relationships, not to be confused with the cofunction relationships, which are complementary angle relationships. Remember that cosecant is the reciprocal of sine, so cosecant of x is 1 over sine of x. Secant is the reciprocal of cosine, so that's going to equal 1 over the cosine of x. Cotangent is the reciprocal of tangent, so it's going to equal 1 over the tangent of x. Also remember that tangent of x, I don't know if I've given you this one before, but it's sine of x over cosine of x. Because tangent is y over x. And on the unit circle, remember on the unit circle that y is sine of x and x is cosine of x, not to be confused with the angle measure x. Okay? Cotangent is the reciprocal of this, so that'll be cosine divided by sine. These identities are going to be used to simplify some trigonometric expressions in the upcoming examples.